Well, I seem to have just lost the video that we just made, and on this molecule. So maybe I'll just rather than redo it, we'll just go over it again, and it's already filled in. So sorry about that. The first thing that we did was to write in the carbon atoms where we know they exist. The second thing is to make sure that all the atoms have an octet of electrons. Sorry, that's a lie, not the second, that's the third. The second thing we do is to make sure that carbon has 4 bonds, and so we added the hydrogens where required. We know, for example, here that carbon already had 4 bonds, but here it needed a hydrogen. Here it already had 4 bonds, and here it already has 4 bonds, but the rest of these carbons had a hydrogen, not this one, but this one and this one, and the same thing was mirrored on this side, and this one already had 4 bonds. Now, the third thing we do is to make sure that these atoms have an octet of electrons, specifically now the atoms other than C and H. Halogens will often find them as these satellite atoms pulling electron density away from the center of the molecule. It adds to the stability of the molecule. They are very electronegative elements. They are close to fluorine in the periodic table. Therefore electronegative, because fluorine's the most electronegative. And so what I've drawn here is the fact that this is a polar bond, creating a little plus sign here in the direction of the electron net pull, and that's towards the more electronegative atom. And so we see that each of the CCl bonds are polar. And I remarked that overall the molecule is polar with kind of a net vector going this way towards the electron density cluster up there. It's kind of symmetric between here and here, but there's no electron density down here to balance out this one. So it's polar in that direction. Getting back to chlorine and the octet satisfaction here, the chlorine needs 8, it has 2, so I have 2, 4, 6, 8. 2, 4, 6, 8. So I added 3 pairs of electrons to each of my satellite halogens. And just to add here, what is the formal charge on this halogen? And remember that formal charges of 0 represent very stable configurations. Chlorine has 7 valence electrons, so it would be 7 minus all of the lone pairs, so 7 minus 1, 2, 3, 4, 5, 6, all of the lone pair electrons. 7 minus 6 is 1, minus half of the shared. There's 2 shared, or we just say minus the number of single bonds. So 7 minus 1, 2, 3, 4, 5, 6, 7. So that's 0. So we often find halogens that have a single bond like this on the outside of the molecule with 3 lone pairs. We're realizing now what we learned in formal charge consideration, that that's actually constituting a 0 formal charge. Carbon with 4 bonds constitutes a 0 formal charge. Hydrogen with 1 is a 0 formal charge. So everything here has its formal charge as not just close to 0, but 0. And so the sharing of electrons in this overall covalent molecule couldn't be better. So it's a stable molecule. What we did once we drew this all in and readied ourselves for just a clear inspection of the questions was to answer what is the electron group geometry and the hybridization state at the same time, because they're based on the same criteria. So we don't consider these atoms because they're not in the middle of an angle, so they're not central. But all of the central atoms can be addressed by these 2 questions. So starting with this carbon, the electron group geometry, 1, 2, 3. Remember, count multiple bonds effectively as 1 because it's based on how they repel, and these guys don't split apart. So electron group geometry here is 3, so therefore trigonal planar, and the hybridization state for a need of 3 would be sp2. And so I'm going to go around the molecule naming the electron group geometry and then the hybridization state. Electron group geometry and then the hybridization state. So trigonal planar, sp2. Trigonal planar, sp2. Trigonal planar, sp2. Same thing, same, all the way around this flat ring. Yeah, it's flat because it's planar, planar, planar. They're all part of each other's plane, so they must all be in the same plane. This carbon, tetrahedral, sp3. Tetrahedral, sp3. Back to the plane. Trigonal planar, sp2. Trigonal planar, sp2. Trigonal planar, sp2. Same, same, same. All that. That's it. The chlorines are not central. The molecular geometry. Trigonal planar all the way. For carbon with 4 bonds and no lone pairs, for anything with no lone pairs, the electron group geometry is the same as the molecular geometry. So trigonal planar all the way around. Tetrahedral, tetrahedral, trigonal planar all the way. So very flat, flat, and then popping in and out. Bond angles, trigonal planar, therefore 120. This one, 120. How about this one? C, C, C. Look at the central atom. It has a geometry of, a molecular geometry of tetrahedral. Therefore, this bond angle, 109.5. Same with this one, and same with this one going to the back. Whereas once I get to trigonal planar geometries, the bond angles are therefore 120, 120, 120, and so on. And I think that's everything on this molecule. So we'll do the last two in their own